Good afternoon, everyone. Uh, in last class, I am discussing about your accidents. So, in last class, I discussed about your accident analysis and also accident studies. So, basic importance of accident study we discuss. Next, we discuss various objective of the accident studies. I also discuss these things. Next, I discuss cause of accidents. So there are five basic elements in a traffic accident. First is your road user, second is your vehicle, third is your road and its condition, next is your traffic, next is your environmental factors such as weather, visibility, etc. I discuss all the things. So accident study and record. So the various steps involved in accident in traffic accident studies are: first, collection of accident data; second is preparation of accident report; third is preparation of location file; fourth is preparation of diagram showing the type of collision; and next is application of the above records for the safety measures to prevent similar accident at the same location. So collection of accident data involves so many things. So I discuss all these technical aspects. Next, I also discuss how accident investigation will be done and uh, accident investigation and study. So basic first is accident investigation, analysis of individual accidents, statistical analysis of accident. So first point is our accident investigation. I also discuss the things. Statistical analysis of accident. I also discuss the things. Next is measure for reduction in accident rate. So first one is we do engineering for reduction of accident rate. Next is enforcement of various law, or third is our education. So if we provide or if we give adequate knowledge to the road users, then our uh, then our accident rate will be decreases. So these are few basic points. By considering this basic point, we reduce or we minimize our accident rate and also accident. Next is engineering measure. So first, road design. We provide road design in such a manner that minimum accident or minimum casualty take place on our road. Next is preventive measures of vehicle. So we provide various preventive measures to vehicles such that the reduction rate of accident will be shown. Next is before and after studies. We do analysis at various points where accident will be taking place. Next is lighting. So we provide adequate road lighting around the road such that our road accident will be minimized. Next is enforcement. So speed control, traffic control devices, training and supervisions, medical check, special precautions for commercial vehicle, observance of law and regulation. These are various enforcement by which our accident rate will be minimized. Next is our education. So education to road user and safety drives. We provide these things to our road users. We provide education to our road users or safety drive to our road users. Then accident or accident rate will be minimized. Next, I'm discussing about analysis of initial speed from skid resistance. So our first point is first point is analysis of analysis of analysis of initial speed from skid distance. Analysis of initial speed. I N I T I A L. Analysis of initial speed from skid distance. Initial speed from skid distance. from skid distance. Analysis of initial speed from our skid distance. So first point, how we analyze our initial speed from skid distance. So the basic equation for finding the braking distance or skid distance, that is denoted by S, for a vehicle of weight W to slow down from speed v1 to v2 meter per second, is obtained by equating the reduction in kinetic energy with work done against the friction force. So we know friction force F is equal to W into F, where F is our average friction coefficient or skid resistance developed between the surface and the tire. So we know the relation between kinetic energy and the work done against the frictional force. So just apply that equation. So here just we know w w by 2g, w by 2g, w by 2g into v1 square to v1 square, v1 square minus v2 square, minus v2 square minus v2 square is equal to work done due to frictional force, is equal to work done due to F into S, F dot S. So here just equate S is equal to this S value is equal to v1 minus v2 by whole square. Here this F and this W and W got cancelled. So here this W and this W get cancelled. So here we get S is equal to v1 square minus v2 square. S is equal to v1 square minus v2 square minus v2 square divided by v1 square into v2 square divided by 2gf. So here we write 2 into g into f. So here 2 into g into f is written. Now substituting the value of g, acceleration due to gravity, is equal to 9.8 meter per second square, and put the speed in v1 and v2 kilometer per hour. So here this speed is in meter per second. Also this speed, small v2, is in meter per second. So just write here, this is curl v, that means this is v, that means speed in meter per second. Also this speed is in meter per second, this speed is meter per second, this speed is also in meter per second. So what we do here, in this equation we just substitute the value of g is equal to 9.81 meter per second square in this equation a, in this equation a, and also we put the value of our capital V, that means a small v, meter per second speed is converted into kilometer per hour. So here what we get, here we get S is equal to, here write down, z is equal to, g is equal to 9.8, g is equal to 9.81 meter per second square, 81 meter per second square, meter per second square, and also this small v1 is converted into capital v1, and also this small v2, this small v2 is converted into capital v2, this small v2 is converted into capital v2, that means this speed in kilometer per hour. Now put the all in this above equation a. So put the all equation in, or all thing in equation a. So what we get, we get here, we get here s is equal to, s is equal to, s is equal to v1 square, capital v1 square, capital v1 square minus capital v2 square, capital v2 square divided by 254f, 254f, 254 into f. So here this is the value of skid distance or braking distance. So this value be obtained. So this is the skid distance or our braking distance. If the skid distance s is measured from the skid mark, the initial speed v1 may be calculated from the relation. So we know a basic equation of our v1 in kilometer per hour also, and also in meter per second also. So we know relations of our v1. So v1 is equal to, we know v1 is equal to root over v1 is equal to root over v2 square, v2 square plus v2 square plus 254 fs, 254 f into s. So here we just calculate v1 from this equation. From this equation, just we calculate the value of v1. So v1 is equal to under root v2 square plus 254 into f into s. So if the vehicle comes to a stop after the skid mark s, then this v2 would be 0. So in equation here we have two equations. So for this equation, this b equation, the value of v2 comes out to be 0. So you all kept a point in mind, that is, if the vehicle comes to a stop after the skid distance s, then v2, here this v2 comes out to be 0. So basically you put this v2 as 0. So what will the value of v1? So v1 is equal to under root 254 f into s. Now we have various accident type. First is collision of moving vehicle with parked vehicle. Next is our two vehicle approaching from right angles collided. Next, so just we have different relation, and we have different equation for these accident type. So next is our accident type 1. So I discussed two type of accident, so or analysis of two type of accident. So accident type 1, accident type 1. So here is our first type, accident accident type 1, a double c, accident type 1. So we have different type of accident. Accident type 1 is collision of moving vehicle with parked vehicle. So when our moving vehicle will collide with a parked vehicle. Suppose a vehicle A moving with, so I write down here accident type first. So this is accident type first. Accident type first. This is our type first. It is our collision of moving vehicle with parked vehicle. So this is our collision collision of moving vehicle with parked vehicle. Moving vehicle Collision of moving vehicle with parked vehicle. So here I write down collision of, just wait, collision of moving vehicle, collision of moving vehicle with parked vehicle, with parked vehicle, with parked vehicle, with parked vehicle. So what will happen? Collision of moving vehicle with parked vehicle. So what happened? So suppose a vehicle A moving with a speed v1 meter per second skids through a distance s1 after the application of the brake, and it collide with a part vehicle B, and two vehicles skid together through a distance s2 before coming to a stop. So the objective of analysis is to estimate the initial speed of vehicle A. That means, what is the speed initial speed of vehicle A which will collide with the part vehicle. So we have our aim or objective to analyze or estimate the initial speed of vehicle A. So step we have two step. Step A is before collision, step 2 is after collision. So what will happen? So you just observe. So we have two step. Step A, here we have two step. So this is our step A or step first. So step first is before collision. So here, this is our before collision before collision. So what will happen? The vehicle A of weight WA moving with initial speed v1 meter per second. So here we take our speed in meter per second, and the weight of our vehicle A is WA, and applied brake skid through a distance s1 and attain a speed v2 meter per second just before collision. So from a relation which I discussed earlier, from that relation we calculate the value of v1 and v2. So here our value of v1 is equal to, we know v1 square, v1 square is equal to v1 square is equal to v2 square plus 2f into s. So v1 square is equal to v2 square plus 2g plus 2g f into s1, 2g f into s1. So this is the initial speed in meter per second of our vehicle A. Now the above equation or this equation represents the slowing down process from initial speed v1 to v2. Next step is step 2, that is after collision. So after collision what will happen? We have to analyze also that thing. So step 2 is our after collision. Step 2 step 2 step 2 is our after collision. Before collision, next is our after collision. After collision. So assuming a fully plastic impact, so the coefficient of restitution E is equal to 0, and the moving vehicle A along with a stationary vehicle B of weight WB. So both start moving together at a speed of v3 meter per second. So the relationship between v1 and v2 is given by the momentum equation. So what I say, so at collision, assuming we assume a fully plastic impact, so the impact between the moving vehicle and the parked vehicle will be a plastic impact. So the coefficient of restitution, that is E, is equal to 0. So the moving vehicle A, which is our moving vehicle, we already take our moving vehicle as A along with the stationary vehicle, or our stationary vehicle is B of weight WB. Both start moving at a speed of v3 meter per second, because after collision with moving vehicle and our stop vehicle or our parked vehicle, both vehicle will moves with the speed v3 meter per second. So I already say these things. Next is the relationship between v2 and v3 is given by the momentum equation. So we know the basic momentum equation. So So here uh, we just derive or we equate the relationship between V2 and V3, which will be given by momentum equation. So WA is equal to beta Vacuum A. Here this G value is acceleration due to gravity. This V2 is your this V2 value is your I think the uh, the vehicle A with bit A moving with initial speed v1 meter per second applies brake skid through a distance s1, and that after skidding the vehicle A will attain a speed of v2. So this is also the speed of your vehicle A. So here we get WA into G into v2 is equal to WA plus WA plus WB plus WB divided by G into V3. So here WA plus WB into G into V3 dot V3, or we get V2 is equal to, or here we get V2 is equal to, or here our V2 comes out to be V2 is equal to WA plus WB, WA plus WB by WA by WA by WA into V3 into V3. Next, what we do, this all the value we substitute in this equation. So just put all the values in this equation. After substituting all these things in equation, uh, here we just call this equation as C. In equation C we get another relationship. So that relationship is equal to, just I write down here, that is equal to, here V2 is equal to, here also our V2, that means our speed of vehicle A after skidding is equal to, this V2 is also in meter per second. So here you all write this V2 in meter per second. So this V2 is also in meter per second. Here this V2 is also in meter per second. Here this is also in meter per second. This is in meter per second. This is also in meter per second. So what we do, just put these equations in equation C. So after putting in above equation, we get V2 is equal to, so we have to derive a relationship between V2 and V3 by momentum equation. So what will be the equation for V2 with respect to V3 is equal to, V2 is equal to WA plus WB, here WA plus WB divided by WA plus WB divided by WA divided by WA into V3 का square into V3 square plus V3 square plus 2G 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 F into S1, F into S1, F dot S1. So we have to calculate these things. So here we derive a relationship between our V2 and V3. So this is the relationship between V2 and V3. Now we have step 3. Step 3 is also this is at collision. So I just here write this is particular thing happen at collision. So here you write at collision what will happen. So this is at collision. So this is basically at collision what will happen. Next is after collision. So vehicle A and B skid through distance s2 before coming to a stop. So velocity v3 reducing to v4 is equal to 0. So the relation of v3 in terms of s2 is obtained again from the equation, from this equation. So from the equation also we try to find out or relate a relationship between V3 and S2. So our third step is after collision. So the vehicle A and B skid through distance S2 before coming to a stop, and velocity V3 reducing to V4, and the velocity at V4 is equal to 0. So the relation of V3 in term of S2 is obtained again from equation C. So here we say, so just here we say, in a step 3, what we do, we have to find relationship between V3 and S2. So this is our step 3. So this is our step 3. So this is our step 3. So here we find or derive a relationship between our V3, derive a relationship between our V3 and S2. So what we do? So just here we do V3 square, V3 square is equal to V3 square is equal to V4 square, V4 square plus plus 2GF, 2GF into S2, into S2, into S2. So here this is equal to, this value is equal to our 2GF, this value is equal to our 2GF, 2GF into S2, because after collision velocity V3 reducing to V4, and our V4, this V4 comes out to be 0. So basically this V4 comes out to be 0. So V3 square is equal to V4 square plus 2GF into S2. Now after collision, vehicle A and B skid through distance S2 before coming to a stop, and velocity V3 reducing to V4, that will equal to 0. So we have a relationship between V3 and our S2. Now substituting this value of V3, substituting this value of V3 in above equation, which we already derived as V2 equal to WA plus WB by WA to V3 square plus 2GF into S1. So just put the value of V3 in that above equation. So what we get? We get the equation like, so we get our result as V1 square. So basically this is our next result. So just wait. This is our next result, that is V1 square is equal to, what is V1 square? V1 square is equal to WA, WA plus WB, WA plus WB by WA whole square, WA plus WB by WA square by WA square into 2GF, 2GF into S2, 2GF into S2 plus 2GF into S1 in plus 2GF into S1, 2GF into S1. So what will happen? Just this is the value of V1. So here we get the value of V1 as under root of this. So the whole thing will come in under root. So this all the things we put in under root. So in kilometer unit, also just convert all the conversation and all the equation of V1 into kilometer per hour unit. So here we get our final result as, V1 is equal to, this capital V1 is equal to under root This is the final result which we get. So under root v1 is equal to 254 254 254 f 254 f s2 into wa plus wb whole square to wa plus wb whole square into wa plus wb whole square by wa whole square plus h1. So this is the complete relationship between our this is the complete relationship between our v1 and s1. So this result we get. So here here every term have own meaning. So here we have different terms. So what that term indicates? So here this wa will indicate the weight of moving vehicle. This wa is equal to weight of moving vehicle in kg. So this wa is equal to weight of moving vehicle in kg. Now this wb is the weight of our parked vehicle, and also this weight is also in kg. So wb is the weight of our parked vehicle. Next is our f. So this f is our average frictional coefficient. So basically this f is our average friction coefficient. Now next term is our s1. So what s1 indicates? So s1 is initial skid distance before collision, and this s1 also comes out to be in meter. So this s value is also in meter. Next is s2. So next is our s2. So what the s2 indicates? So s2 is our ski distance of both the vehicle together after collision. So this s1 value is initial ski distance before collision. This s2 is particularly this s2. So you just remember this s2 value. So basically this s2 value will be our ski distance of both the vehicle together after collision in meter. So when the vehicle A does not apply brake and does not skid before collision, our S1 value is equal to 0, and we have to put S1 value is equal to 0 in above equations. So we have different procedure for the determination of initial speed of approaching vehicle. So in the above procedure which I discussed of accident analysis, it is desired to estimate the initial speed v1 considering the steps A, B and C. So basically we have three steps. First is before collision we take a case, at collision we take a case, and after collision we take a case. So as the vehicle comes to a stop, the final speed v4 is equal to 0, which I already say here that this v4 comes out to be 0. So this v4 comes out to be 0. From this known value of final speed, which will be, we know that final speed will be our stop position. So it is possible to determine the other speed value of v3, v2 and v1. So one at a time by applying in the different equation which I already derived. So this is the uh, step, or this is the condition by which accident type first, that means collision of moving vehicle with parked vehicle, will be analyzed. Next accident type is two vehicle approaching from right angles collide. So two vehicle A and B. So here you see we have two vehicles. So collision of two vehicle approaching from right angles. So here you see our next accident type. This is our next accident type 2. So this is our accident type 2. Accident type 2. accident type 2. Accident type 2. So accident type 2 is two vehicles approaching from right angles collide. So two vehicle, this is two vehicle, two vehicles approaching from two vehicles approaching from approaching from right angle, approaching from right angle, from right angle collides. So this is our another case. So two vehicle approaching from right angle collides. So two vehicle, we consider two vehicle A and B on approaching an intersection with initial speeds v1a and v2 vb1. So we know we have two vehicles, or b, these are the basic condition for accident that two vehicle approaching from right angle that will be collide. So we know we have an intersection, and at intersection different vehicle will coming from different direction. So our analysis is when two vehicle A and B on approaching an intersection with initial speed v1a and vb1. So initial speed of our vehicle A is va1, and the initial speed of vehicle B is vb1 are assumed to apply brake. So skid through distance s1, sa1 and sb1, and the speeds are decreased to va2 and vb2 respectively. Then they collide with each other and start moving, skidding with further reduced speed va3 and vb3 due to the loss of part of energy due to impact, and skid further in different direction through distances sa1 and sb2 respectively. So this is the figure. Just I want to show you all a figure. So if you see here, this is the figure. So here we have an intersection, and on this intersection from different direction different vehicle will be coming. So here just wait. Here what will happen? So here we have a vehicle, here we have two vehicle. Here the first vehicle is our A vehicle. So here this is our A vehicle and this is our V vehicle. So I'm continuing from next session from this part. So everyone join within 5 minutes.